Yeah, I was telling you that projection twice the projecting vector is equals to projecting a single time. So p square is equals to p. So to prove that, I have written p once here and another p here. You can see this form A transpose A and A transpose A inverse. So this becomes what I. I into A transpose gives you A transpose. So the rest part, this part I have written as it is. So what is this is equals to, this is equals to p. So projecting a vector twice is nothing but equals to projecting in single time. Nothing is changed. So p square is equals to p. And also the projection matrix is symmetrical. So p transpose is equals to p. So that you can check here. You have p and take a transpose of that. Whenever you take a transpose of whole this equation, so the positions have to be changed. So this position, leaving the middle one, the position of A and A transpose is changed, and you have A transpose transpose, and the middle part leaving as it is, and here we have A transpose. So it becomes A and this becomes A transpose. And if I change the position of inverse and transpose, I get this. So what is the same A transpose? If I am want to take a transpose, I will have to write this first A transpose and A transpose of transpose. So that becomes A. So look at the expression. This is nothing but equals to P. Sorry for that one. And so you can say the P is symmetrical. And if the A is not a rectangular matrix, if it is a square matrix, that is if it is invertible matrix, and what happens? Your if it is invertible, then A transpose A can be broken into separately. They can be separated. So A into A inverse and A transpose inverse into A transpose. This gives you I and this also gives you I. I multiplied with I, that is an identity matrix. So this is about the when A is invertible. And also you can note on that PB is a when PB is the projection of B onto the that is B in the vector B is projected. So we call it as onto the column space of P. We call it as PB. So when you have this PB and error vector, both are orthogonal to each other. So you can check here B minus P transpose for orthogonality. One vector is taken transpose and multiplied with a P and another column C, column space P, that is PC. So you have, if I am taking B outside because B is common to both, B transpose 1 minus P transpose. So you are having 1 minus P transpose into PC. So B transpose 1, if I P is equal to P transpose, if I take that inside, so I get it as P transpose, I can again write it as P. So P minus P square. So that gives you P square is equals to nothing but P. So P minus P becomes 0. So your value is equals to error, they are orthogonal, both are orthogonal because the value becomes 0. So that is about the projection of the matrices, the properties of the projection matrices. So looking at the problems, so you have a problem here, solve Ax equals to B, solve Ax equals to B by least squares, and so find out P equals to Ax bar if A is equals to this one, and also verify that the error vector B minus C is perpendicular to the columns of A. So first we'll find out X cap, that is estimation of X. So you have this expression already. So just substitute the values of A and find out the this one. So first A transpose is written, then A is written, just multiply them and find the inverse. The inverse you can find it directly through your calculators or the methods you know. So I think here some small correction that is, you can do by this method also. 2 1 1 2 you have, and just write a identity matrix. So try to get this to identity matrix, and whatever changes you find will be the inverse of this matrix. So I have done this 2 minus 1 R1 minus R2 row. So R1 minus R2, then R2 minus of R1, so 3, and it should be minus one small error. You can just rectify that. 1 minus of 1, this becomes 2. And here again I want to make this 1 because I want to make this inward identity matrix. So if I want to do this one, I am dividing it by 3. So I'll have it as minus 1 by 3, and here this has become 3, 2 by 3. And now I have to make this 0, so I'll just add R1 and R2. So if I add R1 and R2, 1 plus 0, 1, and minus 1 plus 1, that becomes 0, and minus 1 by 3 plus 1 by 3, this becomes what? If I'm just adding 1 minus of 3 minus 1, 2 by, this becomes 2 by 3. And here minus 1 minus 2 by 3, that becomes minus 1 itself, because it is minus 1 minus 2 by 3, that is minus 3 minus 2 minus 5 by 3. And if I multiply, check this, this becomes your inverse 2 by 3 and minus 5 by 3. So if I add them, I'll be getting what? 3 by 3, that is 1, and here I'll be getting it as 2 by 3. So just make the correction, or you can just directly calculate it through if a mistake has happened. So you can directly calculate it through a calculator. So what you'll be getting? So you should be getting this values. Values may be correct because the 4 by 3 minus what you have done here, 2 by 3 minus 5 by 3. So it will be something like minus 3 by 3, that is 1 by 3. Just check it out. Okay. You can rectify that. Just multiply whatever result you get, you write down. You will be getting 1 by 3, 1 by 3. And here you are having just you have to find out P, so that I have done. You have A, so that A and X cap you have got 1 by 3, 1 by 3. And I checked the answers. Answers are correct. So you just check the calculation part also. So you'll be getting this P as P, and just find the error. This is E error vector. So B minus, these are the B values, and the projected values what you are getting are these. So the error is 2 by 3 by 2 by 3 minus 2 by 3. And check whether B by 3 is perpendicular to the columns of A. So 2 by 3, you check for each of the column. This column first and next to this column. So how do you check? B minus P transpose into your columns of A. Is not proper. So you can check each of the columns, that gives you the 0. So then you can say both columns are perpendicular to B minus P. Find the best least square solution x cap to 3x equals to 10. You can see the equations. You are having single unknowns, 3x equals to 10, 4x equals to 5. What error E square is minimized? That is what error E square is minimized. Whether when you are finding out by least square method, whether you are getting the minimized error. So that is the question. Check that the error vector is perpendicular to the columns. Same type of question, but only single variable. So 3, 4 becomes your A, and B becomes your 10 and 5. X is a variable. So A transpose B. If I find out A transpose B, you can see we are having it as value 50, and A transpose as A, you are getting it as 25. So what was X cap? X cap is A transpose B divided by A transpose A, that we are doing it. And what is E square? E square is B minus, that is H, you have trans B. So here the error you have to find out is 10 B minus, that is A x cap. So A x cap should be the nearer values of B. B minus B cap. It is similar type B minus B cap square. So that is becoming 3x minus 10 square, or 4x minus 5 square, or you can say 10 minus 3x